study about the gram equivalent mass of oxidizing agent or reducing agent. So there is a particular formula to calculate this equivalent mass of oxidizing agent or reducing agent. So before going to the formula, let us understand what is oxidizing agent and what is reducing agent. So oxidizing agent is a substance which oxidize other substances, and at the same time it will get reduced. I repeat, oxidizing agent is a substance which will oxidize other substances, and this oxidizing agent itself will get reduced. Similarly, reducing agent is also a substance which will reduce other substances, and reducing agent itself will get oxidized. So these two terms are just opposite in their function. Yes. So now you should know what is oxidation and what is reduction. So reducing agent will reduce other substance and oxidize itself, and oxidizing agent will oxidize other substance and reduce itself. Now you should know what is oxidation or what is reduction. So oxidation, so this concept you have studied already in 10th standard. Yes, oxidation is nothing but loss of electron. In terms of electron, we tell it as loss of electron. So this concept, to memorize it in a short form, we take it as LEO. LEO. Yes, L is loss, E is electron, O is loss of electron. Yes. Next one, reduction is gain of electron. So gel, we represent it as gel. This is for memorizing. Okay. So oxidation is loss of electron and reduction is gain of electrons. So now you will be understanding in a better way about the oxidizing agent. Yes. So this concept should be thoroughly understood. Only then the remaining concepts will be easily you will be able to grasp. Okay. So this concept, oxidizing agent and what is oxidation, reducing agent and what is oxidation, this concept should be thorough for you. Fine. Now let us look at the formula. So equivalent mass of oxidizing agent or reducing agent can be calculated by a formula. So formula is like this: molecular mass of oxidizing agent or reducing agent divided by equivalence factor. Yes, molecular mass of oxidizing agent. So which oxidizing agent you are considering? So that oxidizing agent's molecular mass you have to find. Or else if you are considering the reducing agent, then you have to calculate the molecular mass of that particular reducing agent. Yes, divided by N factor, that is nothing but an equivalence factor. Now what is equivalence factor with respect to this oxidizing agent and reducing agent? So oxidizing agent means itself it will get reduced. Yes. So reduced means what? Gain of electrons. Yes. So equivalence factor will be, if it is an oxidizing agent, then equivalence factor will be number of electrons gained. Okay. Now if it is reducing agent, if you are calculating the equivalent mass for reducing agent, then what will be the equivalence factor? Equivalence factor will be number of electrons lost by 1 mole of reducing agent. Understanding? So depending on the oxidizing agent or reducing agent you use, the equivalence factor also changes. Okay. Now if you are considering the oxidizing agent, then what will be the formula? Molecular mass of oxidizing agent divided by number of moles of electron gained by 1 mole of oxidizing agent. And if you are considering the equivalent mass of reducing agent, so in that case how will you write the formula? Molecular mass of reducing agent divided by number of moles of electron lost by 1 mole of reducing agent. Understanding? So that difference you should keep in your mind. Only then you will be able to calculate the equivalent mass of either of oxidizing agent or reducing agent. Now let us study the calculation of gram equivalent mass of oxidizing agent. So the oxidizing agent what we take here is K. KMnO4, potassium permanganate, KMnO4, potassium permanganate. So, when potassium permanganate is used as an oxidizing agent, how do we calculate the gram equivalent mass of this oxidizing agent? So, when we know the formula, we have already studied molar mass or molecular mass of oxidizing agent divided by equivalence factor. So, that is the formula to calculate the equivalent mass, gram equivalent mass. So, because KMnO4 is acting as an oxidizing agent, the formula is like this: molar mass or molecular mass of KMnO4 gram mole inverse, unit is gram mole inverse, divided by equivalence factor N. So, because it is an oxidizing agent KMnO4, the N equivalence factor will be number of electrons gained by 1 mole of KMnO4. So, oxidizing agent is a substance which oxidizes other substances, and this oxidizing agent will reduce itself. So, reduction is nothing but the gain of electrons. Okay, so here because it is an oxidizing agent, the electrons will be gained. So, number of electrons gained by 1 mole of oxidizing agent KMnO4. So, that is your equivalence factor N, and its unit is also equivalence factor unit is equivalent per mole or equivalent mole inverse. Okay, so now let us look into how to calculate this equivalence factor N taking this KMnO4. Okay, so KMnO4, that is potassium permanganate, undergo ionization to form K plus ion, which is a cation, and MnO4 minus ion, which is the anion. Because oxidizing agent is an agent which itself get reduced. So reduction means gain of electrons. Okay, so now we will see how the electrons are gained. So in order to study the number of electrons gained, we have to consider this anion MnO4 minus. Okay, yes. Now this MnO4 minus ion, it is getting reduced to, because oxidizing agent itself get reduced. So MnO4 minus, which is present in the oxidizing agent KMnO4, this MnO4 is getting reduced. Okay, so MnO4 minus is getting reduced to Mn2 plus ion. Okay, Mn2 plus ion. So the manganese present in this MnO4, manganese, Mn means manganese. So manganese which is present in this MnO4 minus ion, it is reduced to Mn2 plus ion plus. Now what is remaining left here? Oxygen atom. How many oxygen atom? 4 oxygen atom. So we have to write that oxygen atom here. So how do we write it? So because it is oxygen atom, so we can write it. We cannot write directly oxygen atom here. So we can write it as water molecule, the form of water molecules. So 4 oxygen will be containing in how many water molecules? 2 water molecules, right? Yes, 2H2O. So now 2H2O means here 2 oxygen atoms are the, it's not 4. 4H2O. 4 water molecules contain 4 oxygen atoms. 4 water molecules contain 4 oxygen atoms. So in order to balance, we write, because on the left hand side of the reaction there is O4 minus, that means 4 oxygen atom is there. So on the right side we balance it by putting 4 water molecules. Okay, now oxygen atom is balanced, here 4 oxygen, here also 4 oxygen. Okay, now here how many hydrogen then? Here 8 hydrogen, 4H2 means 8 hydrogen. Yes, 4 hydrogen molecules. So 1 hydrogen is a diatom. 1 hydrogen molecule is 2 hydrogen atoms. So here 4 hydrogen molecules is there. So 8 hydrogen atoms are there. So this 8 hydrogen atom we will just represent on the left hand side as 8H plus. Okay. So how do you get plus here? Because H2O, when it undergo ionization, it forms. When it undergo ionization, it forms H plus and OH minus ion. Okay, so when we consider only the plus positive charged protons H plus, so 8H plus ions are there, so that you just write it over here 8H plus ion. Okay, so you need not bother about all these things. So I am just writing 4H2O when you undergo ionization, it forms 8H. Now here 8H plus ions are there, so that you just write it in the form of hydrogen, the charge of H plus, so we write it 8H plus. Okay, now let us balance the charge here. both left hand side and right hand side. Now let us look at left hand side. Left hand side 1 minus charge. Yes, 1 minus charge and 8 plus charge is there. 8 plus charge is there. Okay, left hand side 1 minus charge and 8 plus charge is there. Whereas on the right hand side only 2 plus charge is there. Or plus 2 or 2 plus whatever it is. Okay, now minus 1 plus 8. What is it? It is plus 7 or algebra. Yes, minus 1 plus 8, that is plus 7. Here also it is same. You can't do anything, just write it like that. Okay. Now take the for balancing. So how many electrons are gained here? To find out that how many electrons are gained, we just find the difference of both the oxidation state. So here it is plus 7, here it is plus 2. So what is the difference? Plus 7 minus plus 2. So that is equal to plus 5. Plus 5. Okay. So 5 plus 5 is the difference between this oxidation state. So the plus 5, write it here from the left hand side as 5 electrons, E minus. So E minus is nothing but electrons. So 5 electrons are gained when MnO4 minus is getting reduced to Mn2 plus ion. Understanding? Yes. So now this will be the N, that is the equivalence factor for the oxidizing agent KMnO4. Now what is N here? N is equal to equivalence factor. How much? 5 electrons. 5 electrons. The unit for equivalence factor is equivalent per mole or equivalent mole inverse. Understanding? Yes. So now we understood how to calculate the equivalence factor N. Okay. Now let us see the molar mass of KMnO4. Okay. The formula is like this. Equivalent mass of KMnO4 is equal to KMnO4 is oxidizing agent. So molecular mass of oxidizing agent KMnO4 divided by the equivalence factor, that is number of electrons gained by 1 mole of oxidizing agent KMnO4. Okay. So first we need to calculate the molecular mass of KMnO4. So KMnO4 is a compound containing potassium, manganese and oxygen. So atomic mass of potassium is 39. So these values we have to by heart. For simple elements, atomic mass is better to by heart. Okay. So for potassium it is 39. For manganese it is 55. And oxygen it is 4 oxygen atom is there. So for one oxygen atom the atomic mass is 16. So likewise 4 it is there. So 4 into 16. All together when you add you get. Yes. So 39 plus 55 plus 4 plus 4 into 16. So it is equal to 158. 158 divided by 5. Okay. So 39 plus 55. How much? So we can do the calculation here. 39 plus 55 plus 16 into 4, 64. Yes. So 9 plus 9, 18. Balance 1. 5 plus 3, 8. 8 plus 1, 9. 9 plus 6, 15. So 158. So 158 divided by the equivalence factor N. So what is N here? 5 electrons. So 5 electrons. So 158 divided by 5, that is equal to 31.6. So 31.6 gram equivalent inverse is the gram equivalent mass of potassium permanganate, which is an oxidizing agent. Okay. So similarly, you can calculate the reducing agent equivalent mass also. Fine. So it's very simple. Only thing, a little bit of concentration is required in this equation. How the MnO4 minus is getting reduced. So this equation, this balancing is very important. If you understand this, then remaining concepts will be easy for you to write it. Okay. So care should be taken to here while doing this balancing reaction.